Before we begin tonight's proceedings, I'd like to acknowledge the Cadigal people of the Eora Nation, upon whose ancestral land the University of Sydney stands. Good evening and welcome to the University of Sydney for this unique Sydney Ideas Lecture. We are very privileged to have with us Dr. Greg Chamitoff as part of the Faculty of Engineering and IT Dean's International Lecture Series. Previous lecturers have included Australian astronaut Dr. Andy Thomas, Professor George Springer, Dr. Craig Munday, Microsoft Chief Research and Strategy Officer, Dr. Abdul Kalam, the former President of India from 2002 to 2007. I will now give a brief overview of some of Greg's key achievements throughout his illustrious career. In 1998, Greg was selected by NASA as its astronaut candidate, and in 2008 served as the flight engineer and science officer for a 6-month mission on the International Space Station. In May this year, he served as a mission specialist on the last flight of the Space Shuttle Endeavour, STS-134. During this mission, he performed 2 spacewalks, the last of which marked the completion of the assembly of the International Space Station. To date, Greg has logged a total of 198 days in space. Greg is no stranger to the University of Sydney. From 1993 to 1995, Greg taught flight mechanics and flight control in the Aeronautical engineering program, and since then, he has been the adjunct professor of the university. The Faculty of Engineering and IT is ranked as a world leader for our research and teaching. Our undergraduate aeronautics engineering program was established by the Commonwealth Government of Australia in 1939 and was the first of its kind. The undergraduate aeronautic space specialisation was introduced in 2001 and continues to attract the bright undergraduates with the highest entry scores to the University of Sydney. This year, the ATAR was a remarkable 99.45. The school also offers postgraduate coursework programs in Masters of Professional Engineering, Aerospace, and research, MPhil, and PhD programs. The school also boasts a flight simulator, the only one of its kind in the university in Australia, a couple of wind tunnels, and our students build planes, race cars, unmanned aerial vehicles, and a Mars robot, which is currently on show at the Powerhouse Museum. Later this year, we will be launching a satellite into space and then monitoring it from our facilities on the campus. For the young ones here tonight, Greg was inspired at the age of 6 to become an astronaut after watching the launch of Apollo 11 on a family holiday in Florida. As a teenager, he rang NASA and said, "It's my dream to become an astronaut. How do I make it come true?" Well, I think Greg is living proof that if you work hard and you can make your dreams come true. I hope you enjoy this evening's presentation, A Journey Through Space, the final flight of the Space Shuttle Endeavour. Please join me welcome Greg to the stage. Thank you.
Thank you, Dean Johnson. Thank you. Thank you so much for all coming here tonight. It's really great to be back in Australia. I love coming to Australia, and I love living here, and it's going to be hard to leave again when I have to leave again. You know, this is an amazing theater here, and I feel like on this stage I'm going to have to do some kind of acrobatics or something to entertain you all. I wish I could float in front of you or something, but you'll see some of that shortly, actually. I have a video to show you tonight that'll really capture what it's like to be in space. And I'm glad to see some of my old friends here. And this was a very amazing mission just came back from, quite an adventure. And in a way, it kind of starts and ends in Australia for me. The very last thing that I saw about 2 months ago before we came back to Earth, I was up on the flight deck and the shuttle was pointing straight at the ground. And I looked out the window and I saw Australia, I saw the Barrier Reef. And that was the last thing that I saw before we came back down to Earth. So for me, the mission wasn't over until I came back to Australia and got to touch ground here. So I'm really happy to be here. And if you look at the patch, you can see as it says Endeavour on the ship, and there's a connection, obviously to the good ship Endeavour of Captain Cook, and there was a connection made before we actually even flew. As you probably know, the replica of Endeavour is sailing around Australia right now, and about 2 weeks before they set sail, the captain of the replica spoke to the commander of our commander, Mark Kelly, and they wished each other a good voyage, and it was really a really neat send-off. There's also Endeavour was actually, when its first flight, it carried a wooden spike, a wooden nail that is actually in the stern of the replica of the 1770 Captain Cook ship Endeavour. So there's a really neat connection between the two. But let me tell you a little bit about my crew. You may have heard, I don't know how much of the news made it down here, but you remember there was a shooting in Arizona of our Congressman Gabby Giffords. That's Mark's wife. And so this was a very personal event for all of us. We were very close as a crew, and our families are very close. And so it was quite shocking. And that night, all of us were together with our families. And it's really, it was amazing that he was able to fly with us. We were really glad that he did. He's a great commander, and we were a great team. But now he's already left NASA, and he's taking care of his wife. But she was able to make it to the launch, and she's speaking, and so she's on the way to recovery. This is our pilot. His name is also Greg, and so we had to go by nicknames. So his name is Greg Johnson. We called him Box, which is nicknames. We call him Box, Boxman, and lots of other variations. Mike Fink, I flew with him before. When I was up on the space station for 6 months, he came up about 4.5 months into it. And funny thing there, I've been living with 2 Russians for all that time. And, the language kind of goes with the majority of the crew. So I was speaking Russian at all the meals for all that time. He came up, and all of a sudden I had someone to speak English to. And after a couple of days, I realized I was kind of following him around, talking at him. And I said, Mike, is it bothering you that I'm talking you, chasing you around? I realized I was kind of, talking his ear off. But he has a nickname too. It's Spanky, and he gets abused a lot, because it's never the same. It's Spanky, it's Spank-a-link, it's Spank me, it's Spank you, it's whatever. But another thing though is, one thing about him and I, we spent 6 weeks together in space, and every morning he would come by where I was sleeping, and he'd say to me, and this is the way we started every day. He said, "Guess what, Greg? We're in space." And it was just the greatest thing. It was the greatest way to start the day, and so we were looking forward. We got to fly in this flight again together. We were really looking forward to doing that again, and we kept doing that to each other this whole flight. And then Drew. Has anybody seen the IMAX movie, the Hubble movie? Yeah, it's an awesome movie. If you haven't seen it, you really got to go see it. Not so much because it's about a shuttle flight, but because it takes you on this 3D tour through the universe, the known galaxy, and it's just spectacular. He was on that mission, and so he was our lead spacewalker, and so he and I and Mike were the 3 together that we rotated through all the spacewalks, and this is Roberto Vittori, Italian astronaut, and he needed a nickname too, so we called him Ricky Bobby. And I don't know if you know the movie, the reference that's to. He didn't understand that, and then he saw the movie during quarantine, and he still didn't understand it. So, So our launch was actually delayed a couple of weeks, but once we finally got off the ground, it's a spectacular launch. Those who were able to come back, unfortunately, with the launch delay of a couple of weeks, many friends and family were there the first time and then couldn't make it back the second time. So that was unfortunate. But my family was there, and there's my kids and my wife watching the launch. And it's pretty interesting to see it for me from the other side. It's a spectacular launch, but it only for about 11 or 12 seconds, and then it disappeared into the clouds. So you can see here that that's what they saw on the ground. This clock is already past the time when he went through the clouds. But there was an F-15 patrolling the area, which is always the case to watch the airspace when we're launching, and they got this picture from the F-15, which was incredible. And one of the advantages of the delay for us was that President Obama came to see the launch and unfortunately missed it, but then he was there, and so we got to meet us, which was a booby prize. But anyway, we got to meet him. And so this was kind of fun because my family here, they got to meet them. And my daughter's name is Natasha, and I think she goes by Sasha, but it's actually Natasha. So it was very exciting for my daughter to know that the president's daughter was named Natasha. Oh. Now to show you, part of what I'm going to do here is kind of run through the mission and just some of the highlights so that when you see the video, you'll understand what you're looking at. This boom right here is an inspection boom that we use basically to inspect the tiles of the shuttle, to reach underneath. So the shuttle's robotic arm reaches up and picks up that boom off the sill of the payload bay, then reaches underneath and it can inspect the tiles with lasers and 3D imaging systems on the end of the boom. So you're looking at, and this is, well, it's already attached to the space station, but it's the best picture of that boom. But this part here is the shuttle robotic arm, and that's where it grapples the boom. And later on, part of our mission was to install that boom on the space station and leave it up there as an extension for the space station's robotic arm. There was a lot of robotics on our mission, and one of those things is this inspection. And there was some damage that we found. This picture was, I think, taken while when the shuttle approaches the station. We do this backflip, and the station crew is looking out the windows in the service module on the Russian side, taking pictures in a certain scan pattern to try to capture all the tiles. And this is one of the pictures that they took. We're about 600 feet away at the time, and this is not damage you want to see because especially because it's on black tiles, which is the part that gets hottest on reentry. And so we were worried about it a little bit for a while, but the ground eventually said, you know, no problem. We had tools and techniques to go out and repair this, which was all developed after Columbia, but it wasn't necessary. I wanted to show you this, what it looks like to approach the space station, because it's really an amazing thing to be in space following another spacecraft and see it in front of you. It's unreal. It's like out of a science fiction movie. And the shuttle usually doesn't fly in an orientation where you can look out the windows and see that. It's usually upside down and backwards, and that's to protect the windows and critical things in the cargo bay from micrometeorites. But when you're approaching, we flip over to a wings level, nose forward, airplane type orientation. And right in front of us is this other light in the sky, and there's another spaceship, and here we are, like approaching this other spaceship, catching up to it. And as it gets closer, first it's a dot, and then it gets bigger and bigger and bigger and bigger. And we see the space station in training all over the world. There's the simulators in Russia, and then parts in Japan, of course, a lot of it in Houston, and we see it all in parts. But to see it all together and see it floating in space in front of you, it's just amazing. This is something that we really built. 15 countries have put this together, and there it is. It's massive, and it's beautiful. As we get closer, you see it in the overhead windows, and there's a view from inside looking at it. And after the rendezvous, you can kind of see here the shuttle attached. And you may wonder how the heck we got this picture. And because this is one of the last times the shuttle was going to be visiting the space station, it was a priority to figure out how to get a picture like this. There was 6 crew members on the station when we got there. 3 were leaving a few days later, and on a Soyuz. And so what we did was as they left, we did a maneuver with the space station so that they could get a picture out of the side window of the Soyuz to capture this view. So you can see the shuttle, and then the shuttle robotic arm, and even that boom reaching underneath the shuttle for inspection right there. And I don't know if you know the layout of the space station as well as I do, but probably not. I'll just give you a little tour here so you know what you're looking at. But these are solar panels, quite obviously, but these are 240 feet long, so what's that, 80 meters long, these solar panels, massive, massive solar panels. This is about 120 meters across this truss, and about, 80 meters this way. And this is a European automated transfer vehicle. It's a cargo vehicle, and it brings up a lot of supplies. It burns up on entry, so we unpack it and then pack it with trash. This is the main command center of the Russian service module, command and control, living quarters, life support. It's also a Russian module, the first one that came up. And then the border is about here. And then and these solar panels that, that they have some of them are folded up. Ours are providing a lot more power, so we actually provide power to the Russian side now. And this is a new module we have, and you might have heard about a cupola. It's like a 7-sided window that's spectacular that was added after I lived there, and that's on this node looking down. Our airlock, where we do the spacewalks from, is right there, and our laboratory is here. A U.S. laboratory, interconnecting node. This is the European research facility called Columbus, and the Japanese experiment module called Kibo, and a platform for science outside of it there. So that's a quick tour of the whole space station. These are radiator panels. So we docked and come across the hatch. As I said, there was 6 of us and 6 of them. We're all really good friends. We've known each other for a long time, and we trained together at different times. And this is Paolo, another Italian astronaut who was on the station at the time. Dima Kondrachev, he's a Russian cosmonaut, someone I trained with for a long time ago as a backup. And they welcomed us on board, and this is a rendezvous day. It's a very busy day. We just rendezvoused, but we also have to get some things done the same day as well. And one of those is to install some of the things in the shuttle's cargo bay. So you can see the main things that we carried up here in the shuttle. So this is the cargo bay of the shuttle. You see the wing back here. And this was just lifted out of the cargo bay, and it's called ELC-3, and I'm just telling you the name because you'll hear it in the video. ELC-3, it's a platform of spare equipment. There's like spare antennas on there. There's a spare ammonia tank. There was spare robotic equipment. And the purpose of these things, there's a lot of things that are going to eventually fail. We know they're going to fail, pumps and things like that. And we store them on the outside of the space station. And then later on, years down the road, when we don't have this shuttle to support, we have the spare ready to change out. So this was an important delivery of spare equipment. The other thing that we brought up was called AMS, Alpha Magnetic Spectrometer. And this is a really amazing facility. It's basically like a telescope. It's a $2 billion experimental facility. It looks at the background cosmic radiation, looks at particles instead of looking at light. And I'll tell you more about it a little bit later, but it's a pretty amazing piece of apparatus that will be collecting data for years to come. And so anyway, these robotics operations we have to do, and this is fun. I mean, it's basically like flying a video game. You're looking at lots of TV screens, monitors, and you change the views from different cameras, and you have hand controllers, and you're controlling translation and rotation, and from different orientations. It's a lot of fun, except it's real. And it's funny because the first time I ever did this, we didn't have this cupola where you had this 360-degree window. We just were looking at the monitors, and it was the simulations on the ground were so good that you just felt like you were still flying the simulator even though this big arm was moving outside. Now, we did this from inside the cupola, so we're actually upside down, head toward the Earth, manipulating the controls, but outside the window we can see the big arm moving, and it's a bit of a different perspective. But this is the shuttle robotic arm attached to the ELC spare parts platform, and the station robotic arm grabbing it here. And I was with Box in the cupola with the station arm, basically taking this, then installing it on top of the truss. And then the next day we did AMS. So here's AMS coming out of the payload bay. And handing it off also to the station arm, went on a different place on the truss, and there it is being installed. The robotic arms are all Canadian built, and they're amazing. They're like, this one's like an inchworm. It has 7 joints. It can grapple at both ends, and when it grapples, it not only can grapple, but it's grappling, and then it has power and data and video that can be transferred through that end. So we could actually like attach one end, move and put the other, use the other end to grapple something, or to put that other end down and then lift up the first end. And all the time it can be handling payloads or whatever and provide data and power and video through the arm. So it's a pretty capable system. And it's, it's about 20 meters long. It's quite big. One of the things we did during the mission was kind of neat. We talked to the Pope, and he said some nice words. You'll hear those in a minute. And we had 4 spacewalks during the mission, and this was about 1,000 hours of preparation for these spacewalks. And Mike and Drew here are getting ready for one, checking out the suits, and Mike and I here are getting ready for a spacewalk. When you do that, you're basically to avoid the bends, because you're going to a much lower pressure in the suit. We have to pre-breathe oxygen. So that's what we're doing here, is we're pre-breathing oxygen, and actually we lower the pressure in the airlock. We sleep in there overnight, and then we go through a whole sequence of breathing more oxygen and getting suited up, and by the time you get out the door, you've gone through this profile that makes sure you don't get the bends when you get out. Very similar to scuba diving, except you're kind of going up first instead of down first. And so here's more work in the airlock getting ready. This is me and Drew getting ready to go. And this was me outside the airlock, for the first time. And you'll see we have these stripes on our suits to help. It really helps. We know who we are, but the ground doesn't know who we are. So they're looking at camera views and they go, "Who's that?" So a solid red stripe is Drew, a broken red stripe is me, and no stripes is Mike. But anyway, this is coming out of the hatch, and that it's just such an amazing thing that we can do this. I mean, it was my first time, and I've been my whole life I've wanted to do this, and all of a sudden, open the hatch, look down, and there's the Earth, 220 miles below, and it's just unbelievable. And we've done this a lot. And the whole procedure about doing it is complicated, but so well developed at this point. It's almost routine, but it's like being in a movie. It's just hard to believe that we really do it. And over the course of 2 spacewalks, it was about 13 hours for me that I was outside. And I think I spent the first hour all choked up and heart. I was making the suit wet because I was crying in there. I couldn't believe I was there. By the end of the 13 hours, I could believe it and enjoy it and look around and really appreciate it. But there was one time, and at the risk of repeating this for a few of you who have heard me say this, there was one time that it just stuck in my memory. It's burned in my brain forever. It was at night. And I was just experiencing the moment, and I had my hand on a handrail, and your lights from the helmet light up at just a certain part of the truss right in front of you, and we've trained so much that even if you only see a little part of the truss, we know where we are, we know what we're going to do next. It's it's just we don't have, no matter how we're feeling, we know where to go next. But I'm looking at this part of the truss, that's all I can see, and I kind of pushed myself off and just turned around, and everything else was just black as, it's as black can be, and you know that it's a void. You know that it's not a wall there. And I looked back at my hand, and I just thought, like, everything that I know, everyone that I know, everything in my life that has led up to this, my kids, my house, everything is represented by this one handrail. It's the only thing that I could see. And out here is like this infinite unknown that, obviously it was at night, so the sun wasn't up, the moon wasn't in view, and the nearest thing other than the Earth in some direction was trillions and trillions of miles away. Just an amazing feeling. It's sort of the edge of the human reality. It just felt like on the edge of a cliff. It was really a neat experience, and I hope many more people get to do this someday. Just to give you a sense of scale. Yeah, that's me in the middle there, and there's Drew. way out on the end. And this is just one tiny part of the whole space station. This is, you can't even see the whole, these are solar panels. You're looking at just a tiny part of them. And this little platform right here is another spare equipment platform. And on top of it are these exposure facilities. And these have been very successful experiments. Basically, they're exposing materials, computer chips, solar panels, paints, and other materials to the vacuum, the temperature extremes, the radiation environment of space, and to see how well they perform. And then to use that in building satellites and protecting, future vehicles. And there's been a lot of design changes to things for satellites, and a lot's been learned by that, and a lot of different academic and commercial users have put experiments in there. So we took a couple of those things out. They've been out for about a year. We put them in the shuttle cargo bay. We put a couple of new ones out with another several thousand experiments on them. That's one of them right there. That's what it looks like. And there's Mike. Look, he's basically at the end of the boom. So one of the things we did was we took that boom from the shuttle for inspection, and we put it on the station, as I said, and it has at the end of it a grapple fixture, but it's designed for the shuttle arm. So this is it right here. We took that off, actually cut some wires inside, and then put a new one on that's made so the station arm can grapple it and use it. But this was fun because it was like surgery in space with these bulky gloves. And I was standing on the end of the other robotic arm that was holding me. And Mike was like handing me the scalpel and handing me the tools, and then we opened it up and there's all these wires. And I said to Mike, Mike, I don't remember the red one or the blue one. And he said, cut both of them. But here's a nice picture of Mike and Drew out there. And one of my favorite pictures of Drew. And this is of me. Mike took this picture of me, and it's with a wide-angle lens, and that reflection in the visor is of him. So it's pretty neat. And, there's a lot of stuff in this picture, but it's hard to understand. It's like there's a robotic arm. That's part of the Japanese experiment module. There's a shuttle wing down there, a shuttle radiator back there. So the shuttle's like right behind me, and here's another picture. This was a very special moment because one of the things that we accomplished on our mission was we finished the assembly of the space station. It was the 36th flight of the shuttle as part of building the space station. And during this spacewalk, the last spacewalk of our flight, we hit over 1,000 hours of spacewalking time to build the space station. So that mark came during this EVA, this spacewalk. And so after 12 years with 15 countries, we had finally finished assembling the space station during this EVA, and we got to close the door. Mike and I got to close the hatch on the final spacewalk of the shuttle program. So that was really something. And this was something we knew was going to happen. We were climbing up to the highest point on the space station, and this was spectacular. I knew this was coming because we have like a virtual reality simulator where we practice some of this stuff, and I was sitting in the simulator looking around like, wow, this is going to be amazing. And because we knew this was coming, we took a special 10.5mm lens out there, and NASA, of course, has got to certify everything for space flight, and there's no way they could certify the lens to do this. So we took up a lens intending to trash it, and to take this picture of the whole assembly complete of the space station from the highest points you could climb up to. And Mike and I climbed up there right at the end of the EVA. We had a task to do up there, and we got to watch a sunrise from up there. And what an amazing moment it was to share with all the control centers around the planet, looking down on the whole space station completed, and the successful accomplishment of all these space programs from all these different countries working together. It was really an amazing moment. And on the inside, there was some science that we did. Roberto was there as an Italian astronaut, partly with the science program, but also partly to represent the European Space Agency for the AMS, that experiment I'll tell you more about in a minute. But so he and Box were doing some science. And there's a lot of transfer. The shuttle carries a lot of cargo, and so Ricky Bobby here, he was in charge of making sure all the stuff we brought to the space station got put in the right place. And here he is in the European ATV cargo vehicle setting some stuff up. And Mike and I, this is Mike, Ron was on the space station already, and they're pulling out the carbon dioxide removal assembly. It's basically the thing we use to scrub the atmosphere from carbon dioxide. And this was neat because Mike and I had been up there together before. We were station guys, and the ground, welcomed us. Welcome back, to station guys. We're happy to have you, and we got some serious work for you to do because there was some. This was basically a maintenance task that you wouldn't give a shuttle guy to do because if you need to know what you're doing. And so Mike and I had to replace these scrubbers from this unit. And I don't know if you can see all the hoses and connectors or whatever, but we had to take the whole thing apart, change that thing out. It wasn't designed to do in space, put it all back together. And at the end of 9 hours, both of us working together the whole day, we're like, no extra parts, no, where does this go? There's one thing missing. We're just really worried about that. But anyway, we had a great chance to relive our days as space station crew members for one day and do some useful maintenance work. Here's Mike having fun with it. And we also did a lot of other tasks like that. The two of us, we put in some extra lines inside the station for power to a backup antenna. We changed out some circuit breakers that went bad. And we also put in a new line for an oxygen generator, basically to control the pH of the water and the oxygen generator. Some stuff that's dangerous to do because you're working with hydrogen and oxygen, and you have to be careful. So anyway, we had a good time doing that. It's funny because we did so much stuff on this mission, it's almost easy for us to forget the priority of this mission was actually to bring up this AMS, this alpha magnetic spectrometer. And just to give you an idea, what it's about, I'm sure you realize most of what we have learned about the universe, we've learned through telescopes, looking at photons coming to Earth, from other galaxies, and of course we're looking in the past as you look further and further away, and there's still some major puzzles to understanding how the universe came to be the way it is. The Big Bang theory predicts there should be more. There should have been an equal amount of matter and antimatter. And so what happened to all the antimatter? Maybe there's antimatter galaxies out there and we just don't know. And so one of the things AMS is looking for is antimatter. And so if there is antimatter galaxies, it'll know. It'll actually know. It'll see a particle come from a certain direction, be able to recognize its antimatter, and be able to say, yeah, that galaxy is where it came from, and that's an antimatter galaxy. That would be amazing if it discovered something like that. The other thing is dark matter. The observed rotation of galaxies doesn't match the amount of mass that we can see. And so there's the dark matter is the name for the mass that we don't see, and there's theories of particles and how they should be it should be able to observe to identify dark matter. So those are two things it's looking for, but it's also just characterizing the radiation environment in space. These different accelerators around the world that are nuclear physics accelerators. They only can reach a certain energy level in the particles, and the natural background cosmic rays have energies much, much higher, orders of magnitude higher, and they've already seen particles in AMS with energies much, much higher, like 1,000 times higher than particles that they've been able to create on the ground. So, and it's going to characterize the radiation environment so that as we go beyond low Earth orbit, we'll be able to design our spacecraft to protect, humans and equipment, knowing what the radiation environment is. So it's a pretty important experiment. And I just want to end with this one picture here because this was the spectacular view that I had from the window where I was sleeping on the space station. So for the 2 weeks that we were docked to the space station, I slept in the Japanese experiment module next to a window with this view. And this was the hardest window to give up. Absolutely spectacular. And you can see the starry sky that's unbelievable, and the Earth. This is a long exposure, so you can see the lights on the Earth going by and the atmosphere. But more than looking at what's in this picture in terms of the space station, the really neat thing about it to me is that it represents what we've accomplished with the Space Shuttle program. So after 30 years of work and 12 years building the space station. Now, the legacy of the space shuttle is that we have this amazing space station. There's 6 people living on board. It's completely equipped now to do all the science it was intended to do. And it's a beautiful, beautiful, amazing place that we have, that we humans built. And this view isn't so much a view of the space station, but to me it's a view of the Earth and of our planet from the vantage point of this laboratory that we have people actually living and working in every day. And this place that's the stepping stone to our future. So anyway, this is the memory I'll keep with me forever.
Thank you, Greg, for taking us through some fantastic and fascinating journeys through space. What did you think when you arrived back on Earth? What was your first emotion?
You know, I was glad to be back. It's glad to be, you know, you don't think about the safety when you're doing it. It's too exciting, it's too exhilarating. And, but when the wheels are back on the ground, you feel like, okay, I'm back home, I'm going to see my family again, and it's good to be home.
Thank you. This side, perhaps, and then the other side.
Yeah, thanks for coming. First question, what's the maximum height for an astronaut? Just curious.
Maximum height? Are you worried? I think you're fine.
Great. The second one, a bit more serious. You mentioned when you're on the handrail contemplating infinity. Can you elaborate some more on that? Because I'm thinking you've probably got a better grip on infinity than most philosophers and all that. So,
Are you a scuba diver?
my mate is.
You know, it's kind of the same kind of feeling. You know, I think if you're diving, you know, you're floating in the water, and you have that sense of, well, you see way below you, but you know you're not going to fall. You know, you have that sense of flying. Of course, you feel the water around you, but it's very much that same feeling. And also, like if you're on a coral wall, you know, there's this abyss off to one side, you know, and then there's this, you know, the coral on one side and this abyss that goes on forever. But of course, it's, you know, that's still water, it's still on Earth. So it's kind of like that sort of feeling, but, you know, there's just this unknown out there, and you sense it's even when the Earth is visible. You know, the Earth is so bright actually when it's you know, on the sun side, it's so bright, and all around it, you know, especially with the, you know, with the visor. I mean, you can see this out the windows of the shuttle or space station, but with the visor, you can look all around. You just see the black, you know, all around the Earth, and you know, you see it like a ball, and you see it just hanging there in nothing, and you know, it's just unfathomable. It's amazing. You know, there's one thing that I saw this time that I never noticed before, and I think it was because I was outside, and it happened to be Saudi Arabia. You know, when you're looking down through a window, and you know, and you're flying over, let's say, Australia, you know, you can see the horizon is curved, you know, but you look down, you see the land, it, you know, looks flat. But I think Saudi Arabia is just the right size at the altitude we were at, that you can see the whole thing, and you can see that it's, you know, from the right angle, I could see that, you know, it's on, you know, that it's on a sphere, and the shape of it, it's not, you know, it's not flat, it's a chip, you know, it's like somebody painted a basketball and then took the chip off, you know, and it was just this perspective that the continent, you know, wasn't flat. It's incredible to see it all with your own eyes, you know. You know that's the way it is, and you know that's the reality, but it's this confirmation, you know, of the reality that you know. To see it with your own eyes, it's hard to describe.
Thank you very much.
Sure. Over here on this side.
I was just wondering, what sort of rehabilitation and stuff do you go back when you come back to Earth? Do you have to go through?
This time it was really easy. The last time it was 6 months for me, and rehabilitation took a long time. The first couple days, you know, the first day I couldn't even sit up. And it took about 3 days before I could, you know, kind of walk, holding onto the walls. The funny thing I remember back then was, you know, the first night, I was trying to get to the bathroom you know, they left me in a room, and I said, don't worry, I'll be okay. And I just tried to get to the bathroom, and I was crawling on the floor. And I fell while I was crawling. I mean, I was just crawling and still fell, you know. And it's very, very disoriented. Gravity, it's really amazing how your brain deals with gravity, because, you know, if you think about it, you know, it's a constant bias, you know, that's always there, and your brain knows to ignore it, you know. and it knows when it senses something different, and it knows that's a turn, but there's this acceleration that it knows to ignore it and not consider it a turn. And you turn your head like this, now the acceleration from gravity is this way, and your brain knows right away, ignore it. It's 1G, it's in the direction change, and it can ignore it. What happens is you go into space for a while, and you don't feel that for a long time, and then you're really sensitive to it, and every little motion, all of a sudden, you pick it up. When that picture that they took, that from the Soyuz, where the shuttle was attached, that was in the middle of the night, and I was sleeping, and I woke up because the space station was maneuvering a little bit, and I woke up because I felt something change. In your brain, you feel the tiniest motions. The gains are kind of all turned up, and then you come back down suddenly, and that gravity vector, your brain just says that's a wicked turn. Yeah. And so you can go like this, and you just feel like whew, like you're really making a fast turn, and this time I was able to play with it because it was only for a couple of weeks, and the recovery was really fast. It was we were having dinner. Some friends here were having dinner like that night, and so it was a really quick recovery. But it was fun because I could play with it this time. I kind of turned my head and go, wow, that's pretty cool. And an hour later, it's not as much anymore. Your brain after about a day, your brain figures it out. It's pretty neat.
That's cool.
So. Over here.
Greg, when you're removing something like the CO2 scrubber, I guess you've got a box of tools that you've got to select. You've got, when you're working on it, maybe you've got loose bits and pieces like nuts and bolts and washers, clips of wire. How do you stop all this stuff just moving away? How do you keep the tools in the box? Could you just tell us a little bit how you work around those problems?
That's why they gave me and Mike the job instead of the guys who hadn't done that kind of thing before. Because there's a procedure to follow, there's tools to go get, like you say. But what we did is we went and got several container bags, that have zippered pockets, and every time we took off a piece, we put a piece of tape on it, put a number on it, shoved it through opened the zipper a little bit, shoved it in the bag, and then went to the procedure and marked on the procedure where we got it from, and that enabled us to put it all back together in the end. And if you didn't do something like that, you'd have a hard time. And it's something that it's funny because the guys who haven't spent as much time up there, you can kind of follow them along in the space station. They keep knocking stuff off the walls, and you keep putting it back on, as they go through. So you get used to being careful and moving carefully, and it's very common to put something down, or attach it to the wall with Velcro or whatever, and then you're just working on something and you change your orientation, and then now you're over here and what happened to it? It's gone. You start looking all over the place, and it's totally a different place than you thought you put it. And but you get used to it, and then you start taking advantage of that. It doesn't take too long. So we're very adaptable. It's amazing how adaptable we are.
Thank you.
G'day, Greg. Firstly, thanks very much for spending tonight with us and taking time out of your life, and congratulations on all your life's achievements. It's excellent. But my question is about the Atlas program and the potential of possibly going to the moon again, and if that's ever going to happen. Sorry, I'm a bit emotional. I didn't get to see STS-133. I stayed there for a week and a half and never got to see a space shuttle, so I'm seeing you now, so that's probably...
Hopefully this gave you a real sense of what it was like to be there. Yeah. It's, this is a difficult time right now, as you probably know, because the shuttle program has ended and we don't have a replacement vehicle, and we, the plan, in 2004 was we're going to retire the shuttle along this path, and we're going to build the new vehicle, which is supposed to go to the moon and eventually Mars and asteroid. And those two paths just got disconnected. They should have been connected by milestones, and we didn't get the resources to develop the new vehicle. There were some delays, and eventually Obama appointed a committee to review how it was going, and that committee correctly said, hey, this has got problems, it's costing too much, and there's more money is needed, and it's probably not the best way to go. And I don't think anybody really faults the committee for that review. It was sensible. But the problem is the shuttle retirement wasn't correlated with anything anymore. So we just all of a sudden get to the end of the shuttle program, and there's nothing we can do about that. And now we don't have a replacement vehicle. But the sort of three efforts now, you know, and unfortunately there's this perception in the media says, you know, it's the end of the, you know, without knowing better, end of the shuttle program equals end of the space program. Well, it's not the end of the space program. We have this million-pound, you know, spacecraft in orbit that all these countries are working together, you know, to support now, and we're going to have to get there using the Russian vehicles. You know, all the crews are going to have to get there using the Soyuz for a while. Meanwhile, a lot of resources from NASA are being diverted to the commercial sector to try to build private spacecraft. There's a few companies are getting close to being able to at least provide cargo from the U.S. We have the Japanese and the European and Russian cargo vehicles, but soon in November there'll be a launch of another U.S. cargo vehicle. SpaceX is doing that, and theirs is supposed to lead to a crew-carrying vehicle, supposedly in 3 to 5 years. But how long that'll take, I don't know. And you know, in the meantime, we're going to be dependent on the Russians to get us to and from the space station. So we're not really happy about that, but that's what we're stuck with. But the main thing we need to go where you want to go is a heavy lift vehicle. And there's a lot of people, you know, NASA and contractors that we're ready to build this, you know, this next generation heavy lift vehicle that can get us out of low Earth orbit, which the shuttle can't do. And a lot of them have been laid off. And from what I understand, like a lot of them haven't taken new jobs yet. And if something comes down the pipe, they're ready to come right back and, you know, and get to work on it. But if we don't get a decision on heavy lift for a year, we're going to lose a lot of the talent. And this is the thing we're afraid of now, is just losing all the skills and talent of thousands and thousands of people in Florida and Houston and around the country, and around the U.S. So we're waiting for a decision on, you know, what direction we're going to go with heavy lift, and we're hoping that this private sector can get us back to low Earth orbit, you know, shortly. But that's not going to get us to the moon. So it's unfortunately this whole situation seems to have set things back, you know, maybe 10 years from what we were hoping, and that's where we are. So thanks. Hopefully in your lifetime, though, in your career time, it'll be possible.
Thanks, mate. Cheers.
Here.
Why are they sending NASA, but why are they stopping NASA sending rockets, but they aren't? But the other countries are.
Why are they stopping NASA from sending rockets? Yeah. It's not that we're stopping NASA from sending rockets. It's that the space shuttle was designed to do a certain job. And what it's able to do is bring things to orbit, and it was able to build the space station. And but the design of the space shuttle is not as capable as we hoped in terms of how much it costs to get things to space. You know, in order to do more up there, we need something that costs less, and also that's something that's safer. So it was a decision to make the next thing. You know, always when you build something and you use it, and you know, in this case you fly it, you learn something from it. We've learned a lot through the whole space shuttle program. And now from what we learned, we want to build the next thing, which is better. And in order to build the better thing, we have to stop what we're doing and spend money on the next thing. So that's the basic reason, is because we want to build something better. Thank you for that question.
Hi there, Greg. Firstly, I just want to thank you for coming down this evening for one of what I think was the most inspiring talks I think I've ever seen, and I hope that echoes the thoughts of everyone in the room.
Thank you. Pleasure.
I just wanted to ask, I was interested in your story and how from a young age you'd always kind of dreamed of doing it, and you had quite an inspiring story because you rang them up, and we were kind of at the beginning of the space program, or still kind of early days back then. But now we're kind of entering a period where we're looking at the end of the space program, and we're looking at America kind of scaling back what maybe they once did in the past, and also the kind of impending decommissioning of the space station in a decade or so, and then the kind of rise of people like China and their kind of space program. So my question is, what would your advice be to kind of young people in the room who have the same dream as you, and how, if it can seem like it's almost unattainable, how can they go about achieving it? What would they study? And is there any hope for a British engineer in his late 20s?
I think you're in the perfect spot. Well, first I would say that the perception that is going away is just not right. The space shuttle program has ended, and there's a transition time right now, and that a transition time is, it's an exciting time. I mean, there's new things coming, and those new things will hopefully, give us capabilities we didn't have, up until now. And so, there's a lot to be excited about, because the plan is to go beyond low Earth orbit. That's why we're doing what we're doing. I mean, that's why we're stopping, the shuttle, so we can spend the money on going beyond low Earth orbit. So, but it's going to take some time. And I don't think anybody, getting back to the commercial spaceflight thing, I don't think anybody, would say that they didn't think that the right thing to do was to get it to be profitable for commercial entities to work in space, because that's what's going to cause a boom. That's going to, have an explosion of people being able to go in space and profit in space, whether it's for energy or for resources. It's the private sector and commerce that's really going to make it possible for a lot of people to have access to space. So all the stuff that's going on with space tourism and the commercialization of rockets, I think this is all in the long term going to be setting us in the right direction. In the next 10 years, so for my career, it's going to be a little bit of a setback. For your career, it could all be happening just in time. So so don't give up any hope. And you might want to learn Chinese.
and Russian.
No. Okay.
Hey Greg, thank you for sharing your journey with us, and I really enjoyed it, and it's very inspiring. So I wasn't sure, you said you spoke Russian for 2 weeks with the guy, so how good is your Russian? Maybe I should ask it in Russian, and then you can translate just to test you a bit.
Well, for 6 months, I lived up there with 2 Russians. Well, for 4.5 of that months that time, I was with 2 Russians, and then one after that. So, conversation had to be in Russian, basically. But we spent a lot of time training together, years back and forth. A month in Russia, a month in the U.S., a month in Russia, a month in the U.S. So, but I'm never going to feel like I'm fluent. But that was a very actually enjoyable part of all the training, was learning the Russian culture and spending the time over there, and that's one of the neatest things about the whole space station program, is all the collaboration with all the international partners and cultures and people. It really is a wonderful part of it.
Yeah, just to my question, lastly, for a person like you mentioned that walking out of space was kind of personal dream for you, and I'm wondering, for a person like you, do you have anything else? Like, what's your next dream? What somebody like you would like to do?
Well, like the previous question, I always wanted to go to the moon and Mars myself, so I'm still holding out.
Thank you.
But I may have to pay for the ride. I may have to make enough money to pay for the ride. I think that's the only option for me now.
It's commercial. Thanks.
Greg, I was just interested to know the levels of cosmic radiation you receive in space, and if it has to be monitored carefully and how that's managed. And I've got another question. I was just also interested in the shuttle landings, whether they're all automatic or whether some are manual or whether it's a commander's decision.
My son, who's 6 years old, I have a daughter and son who's 6 years old. You saw them in the video. They brought him into the shuttle flight simulator just a few months before our launch, and got my son to land the space shuttle. So anybody could do it. No, he thinks he can do it. After that, he was like, "Why does it have to be a fighter pilot? Because I did it." No, but it was funny because they have this flight control power on both sides, and I was flying on the other side, trying to correct everything that he was doing, and in the control room, the guy was talking in my ear, saying, let me know when you want me to cut off his flight control power. So I was just waiting for the last moment. Okay, cut it now, and but he was busy flying it, and he thinks he put it down. So but it's not automatic. It's not the capability was built in. But I don't think it's ever been used. And basically, the commander takes over just as we pass Mach 1, going from above to below Mach 1. There's kind of a circle. It's called a hack, but it's a circle. It's all managing energy. You want to get to the runway with the right speed, and the way to do that, the way the shuttle does it, is it makes an imaginary circle away from the runway. And as you're coming down, based on the energy that you have, it moves the circle further or closer and makes it bigger or smaller and makes you fly around it. And that way you dissipate the energy just at the right time to land. And usually the commander takes over right as we approach the hack, lets the pilot fly it, because the pilot, the right-seater, wants to have, now it's not going to matter anymore, but we give the pilot stick time, really flying the shuttle, so the next flight he could be commander and fly it all the way down. And then the commander would take over and land it. So, but I'm pretty happy that it was landed manually, because it was a beautiful, beautiful landing. As for the radiation question, yeah, we monitor it. We wear dosimeters. Especially during the spacewalks, there's much higher dose of radiation outside the station. The station, protects us to some extent, and an Earth's magnetic field is still protecting us, at the altitude that we're at, but it's still much higher dose than on the ground. And there's lifetime limits, and they're monitoring constantly with the solar cycle and sensors inside and outside. And we have kind of a lifetime limit we have to stay within. And just to give you a sense of that, the radiation exposure for me was about 10 times higher than it is on the ground, and I've used up about 15% of my lifetime limit. So, and there's just enough left to go to Mars and back.
Thanks so much for the presentation. It was really good.
Thank you.
What age does an astronaut retire?
Do I look that old? The good news is there's been someone on the space station who's almost 10 years older than me for a long duration flight. So there's still some hope for me yet. But there's been career astronauts, into the late 50s. So, and I'm sure as time goes on, that'll even expand. So.
Thank you.
We have time for a few more? Or? Okay, one more question over here.
How did it feel when you came back on Earth?
It's a big difference between, I'm going to think back to the first time I flew, because that's when you really notice that, you're not really prepared for the differences. And the really neat thing is, when you get up in space and you're floating, it's great. I mean, it couldn't be more fun, to be able to float. You feel like Superman, you're flying all over the place. And the funny thing is, you get so used to it, you never sit down. You never sit down. You never have any pressure on your feet, and you sleep floating, and you get so used to it, you wonder what it's like to be in gravity again. And you start to think, wow, gravity is not normal. It's only down there, but up here, you don't feel it. And so it's very strange, because after a long time, it starts to feel like being in zero gravity is what's normal, and being down here is the exception. And then when you come back, and you do a lot of exercise in space to try to stay fit, and you start to feel good. You start to feel, like you're in really good shape. And we do 2 hours of exercise every day when we're up there, and I felt really good before I came back. But then you come back, and gravity is so strong. It's amazing how strong it is. You don't even notice it, but right now you have so much force on your feet, and you're so used to, when you sit down and you do things, you pick things up. Everything that I did, I just couldn't believe how heavy it was. So it's gravity is strong, and what we say is gravity sucks. Well, thank you. I think we'll stop there. Thank you so much for being here, everyone. As you can see, we had a wonderful time. We worked hard, and we had a great mission, and we're very proud of the whole NASA team that we were able to finish the assembly of the space station. And one of the things that really hit me when I was on both these missions is that the accomplishment really mattered in the sharing of it rather than in the specific accomplishments itself. So it's very important to us to share it while we're there, and to be able to come back and share it with everyone who wasn't able to be there with us. So thank you so much for coming tonight. Really, really nice to see you.